Welcome to the first week of Introduction to Chemistry. Chemistry is the study of matter and energy. So the first question you might be asking yourself is, what does she mean by the word matter? Well, matter is things that we think about as being solids, liquids, or gases. And all matter is comprised of tiny particles that we call atoms and molecules. Let me give you an example of some matter, and you can try to guess what types of atoms and molecules are comprising this particular matter. Well, here you can see I have an empty glass. It's actually not empty, there's air in there, and air is matter. Let me pour a liquid into the glass. Are you noticing that when I pour the liquid in, some bubbles are forming at the surface? So it's a clear, colorless liquid. What type of matter do you think comprises the sample that I have inside this glass? Now, some of you probably said, well, it's a clear, colorless liquid. The most abundant clear, colorless liquid I know about is water. Others of you might have realized that there were some gas bubbles in that liquid. So you might have thought to yourself, well, maybe it's a carbonated beverage. All carbonated beverages contain some carbon dioxide. In both cases, you would be right. That was a sample of carbonated water. It has some other things in it as well, like some sugar and some citric flavorings. But that matter was comprised of atoms and molecules, just like all other matter. And the chemical structure of the water and the carbon dioxide, the sugar, and the citric flavorings that are in that particular sample determines the property of that matter. So just to review, everything, all matter, is comprised of tiny pieces called atoms and molecules. Chemists believe that the properties of the substances, in other words, whether the substance is a solid, liquid, or a gas, how high is the boiling point, what does it taste like, what does it smell like, all of those things are determined by the kinds, numbers, and relationships between the atoms and molecules of that substance. Now, scientists have known about atoms for a long time, but it was John Dalton, who was a chemist in the early 19th century, who published a very famous paper where he was actually studying samples of gases dissolved in liquids, and he made some key findings. Generally, these findings are summarized in the following list. He confirmed that elements were comprised of the tiny particles called atoms. Now, he likened those atoms to little billiard balls with hooks on them. If you celebrate Christmas, you might think of those as being little Christmas tree ornaments with hooks on them. John Dalton said that during a chemical reaction, no atom disappears or changes into another type of atom. So his theory had elements of conservation of matter in it. He said that the atoms were the smallest unit of an element that can combine to form molecules, and that those atoms combine with other atoms in whole number proportions. They can combine also with different types of elements to form compounds. There's a lot of new words in this atomic theory. He's most famous for coming up with the concept of atomic and molecular mass, and we're going to talk about that a lot more during this course. So even though Dalton couldn't see the atoms, they're much, much too tiny to see, he was able to observe them in large groups by making some measurements, such as taking the masses of some samples. And he was able to develop his theory that all matter is comprised of atoms, that those atoms combine with other atoms in whole number proportions to make molecules and compounds, and that different types of atoms have different types of mass. In other words, some of them are really big and some of them are very small. Now, when Dalton was around in 1805 writing this paper, microscopes were already invented, but they weren't powerful enough microscopes to see atoms. In the 200 years since he wrote that paper, though, there have been many, many experiments that have supported the theory that all matter is comprised of atoms and molecules. One of the things that happens is that microscopes have gotten more and more powerful. For example, here's a scanning electron microscope picture of some pollen particles, the type of pollen that gets into my nose and makes me sneeze in the spring. I'm told that this particular type of pollen particle is from a redbud tree, and I have one of those in my yard. But even pollen particles are made up of billions and billions of atoms and molecules. Now, as microscopes got more and more powerful, eventually people got to the point where they could see individual atoms. This image is from an instrument called an atomic force microscope. This was an image that was recorded at IBM. And what they did was they took some iron atoms and they used an atomic force microscope to push those iron atoms around on the surface, which was made of copper. These are the iron atoms. If you can read kanji characters, you can probably see that they actually spelled out the word atom by pushing the iron atoms around. So we now actually have visual evidence that there are atoms and that those are the smallest particle of matter that exists. If you divide an atom in half, you actually change the type of element that you have. Now, most of you will be joining me to watch videos every week. But when you watch the videos, you might see topics that make you think, I wish I could learn a little bit more about that topic. Well, there's lots of sources of information about introductory chemistry, but one that I really like is this book by Nivaldo Tro called Introductory Chemistry Essentials. So I will actually be going in about the same order of content as this book, and if you're interested in having some additional practice problems to try, or you'd like to do some reading about this topic, I encourage you to go ahead and buy this book. It's completely optional, it's not required, but I know some of you are interested in learning more, and this is a good place to start doing that. In the next lecture, we'll be learning about the scientific method and how scientists are able to determine that all matter is comprised of atoms and molecules.